Hi, Eric. Good morning.
Good morning, Sammy. How are you?
Good, good. How are you? Finally able to join.
That's right. Yeah. I finally subscribed, so I know when these meetings are now.
Good, good. I send you the link. I press the link. You may request it.
Which link? Oh, there we go.
If you click, you should probably request an access. I will try to provide you. I think what I need is your OCP email address.
Okay. Yep.
Then I can give you.
I'll put that in the chat.
Yeah.
I got a couple other things going on, of course.
Hi Eric, this is Gopi. How are you?
Hey, Gopi. Good. Good.
Good.
Hi,
All right.
Gopi.
Oh, hi Sammy. How are you doing?
Good.
Yeah, with our shuffle here, Gopi, I'm now the sustainability project lead, taking over for where the role Mohan was playing. So.
Oh, I see. Okay. All right. Welcome to the new role.
So I will be more involved in the projects now.
Okay, sounds good. We have been working on and off for years, anyway. So yeah, that sounds good.
Sammy still runs this work group, though. This is I
You
started
can able
some
to
this past
dedicate
fall.
to us, right? Did you type the things that or I could probably get it from the OCP site, your email. So Eric Dylan dot
Yeah, here. Sorry, I'll get back to this chat session and what we're doing here. So many things to do.
Hi David. So today, like I said in the notes, right, I was trying to get the feedback incorporated. I didn't have a chance to complete that this week. I will try to focus on in getting that done by next week. And also we had a discussion on all the OCP profiles. What we want to do is we want to make sure that any power related or any sustainability related items that we want to review and bring it and say like these are the things currently exist in OCP profile. After that, then we can have a discussion on what additional things that we need for IUE related work that we want to achieve. Those two are still pending from my item. I need to spend some time. I will try to focus next week to get those two done. Any opens this team has that you want to discuss today?
I don't have anything. I think we talked about offline, number of items. So we'll bring it up in the upcoming weeks. Yeah.
Yeah. Yeah, we had a kind of detailed discussion on where we want to take IUE portion of it. And we identified a lot of areas that we want to work on it. Maybe some of you probably might have heard. If you want, I can quickly run through those, but trying to understand is any opens the team has today. If not, I think we have Eric, David, and John are new here. If you want, I can quickly go through our thinking on IUE. Is that going to be useful?
Yeah, that'd be very useful, actually. That'd be good. Thank you, Sammy.
Okay. Let me bring a screen here. So the way we are kind of looking for IUE definition is three things we are trying to kind of improve, right? It's basically like PUE side, we are saying IT power, non-IT power. That is a general concept. And we want to take this IT power and slice into what is real IT power versus non-IT power. And that's what we want to really say, like, what is the power coming into this IT and how do we kind of separate it out? The basic formula that we are trying to capture is computational power is server power minus thermal power, power conversion loss, ideal losses at a high level. So now we have to look in all these three items. What is the tower we're going to take those items here, right? So when we started looking in the details, the way we are kind of positioning is, if you are taking ideal power, until this, no real work is getting performed. So we have to subtract from the total the actual power going to be consumed for IT workloads. So this is a loss. And that area what we spend time to kind of look at it is, hey, we need to have a clear definition of what is ideal power really means, right? That's where we were kind of looking, okay, system booted, infrastructure services are running, no work schedule. You may have infrastructure workloads going on, but not real final end user workloads going on. You may be collecting some telemetry or health data, and you have some background.
Have you got the UPSs there captured as well?
Coming in?
UPSs, the batteries.
Yeah, usually the UPSs are part of the PUE equation, but if the UPSs are inside the rack, they would be captured.
Okay, if they're outside of the rack.
If they're outside of the rack, then they're part of PUE, not part of IUE.
Okay, fine. Cool. Thank you for that clarification.
In fact, category 1 PUE is defined to be measured at the output of the UPS, right?
Yeah, I know. I've seen sites that do it differently at times, so apologies. I just sometimes have to check.
Yeah. Right. Well, and actually, that's a good point. It's because part of what Sammy has done here on a different topic that's not the IUE topic is try to tighten up how you measure PUE.
Yeah, if we can do it from the substation which is outside, then that's absolutely fine. That makes sense for everyone. But if they're doing it sometimes from the switch gears, which I have seen quite a few do, and they then bypassing quite a lot of things in the background. So yeah, it's always interesting. So,
yeah, there is a power related item. So since we are talking about three different items out of this one, right? There's ideal power, power conversion loss, and thermal loss, right?
Yeah.
And focusing on ideal loss here. We will also cover the power. I think UPS other things will come into picture, right?
Cool.
Then we need to account for the smart NIC or any DMCs. All this kind of things really like not kind of part of your real IT workload. It's more of a infrastructure for running that, right? And also, how do we operationalize, right? That is a kind of important. How do you detect you're in idle power? Is it a static or is it dynamic that you can measure? We need to kind of really like create some good wording and definition around this to say like, when we say idle power, everybody need to kind of report the kind of same definition, right? That we need to tighten it up. Any comments on this? We have not worked on definition or writing the words, but just trying to kind of identify the items that we need to be accounting for it.
It's good so far. Nice, good.
General question, since we're coming in kind of cold here. Did you talk about maybe manufacturers providing numbers?
Who's going to be providing these numbers?
I'm just saying, if there's a manufacturer of equipment, would you be looking at, like, let's say if they said, well, this piece of equipment provided this idle power.
So that's where I think question is, how do we operationalize, right? We wanted to do a profile, a sustainability profile. As part of that, we would like to get all the information that is needed for this definition. And what we said was we did a review like what is in the sustainability or a DMTF or Redfish profile, what is available. We want to first go and look at what is currently available. Then we need to decide what is the new things need to be reported. To answer your question, yes, we need to comprehend, but how are we going to comprehend that part? We have not discussed.
Okay, wonderful. Thank you.
Then I think what we said is, like, let us also look at the power side of it. When we look at the powers, there's a two power model for the rack. One is a traditional model where your PSUs and things part of your server. Other model is you have a PSU on the rack. It's a TC bus bar. So it's common PSU shared across multiple systems.
Yep.
Then I think we talked about how do we, so we need to really account the losses here as loss from the server perspective. When we look at DC bus bar, we need to look at loss here and loss here. These two need to be accounted. If these are going to be shared, so we need to have a mechanism to represent if you are going to look at the server specific PUE that you want to IUE that you want to kind of aggregate them to say rack level, how are you going to define that, right? So then what we said is your power supply loss for traditional power rack, your power supply loss and the DC converter loss. These two you need to account as part of the power related items. But if it is a DC bus bar, you are going to share the power supply across multiple systems. So you need to really figure out what is the total TDP, and per system, you may not have a homogeneous system, you may have a heterogeneous system. Then how do we account those heterogeneous system? How do you put a factor of the loss from the PSU here to each system? And thinking here is, you can basically like add up all the TDPs, and that's what you want to divide this whole power supply by the TDP. So you'll get a total loss for the system. And based on each system TDP, you can get a factor and you can apply the factor to each server. You may not get it linearly because all the power supply characteristics, but at least to simplify it, we can go with a linear assumption. If you want to go more complicated, you can put a curve and you can figure out how do you want to factor it.
Yeah, are you planning ahead, Sammy, for like the smart power supplies? They have an SM bus connection. You can query them, right, real time. And if you can measure input power and output power, you can figure out what the efficiency is, and then you can just back into what the AC loss is associated with any system by knowing its DC load. Right? If you know the rack power supply efficiency and you know the system load, you can figure out how much of the shared power supply loss applies to this system.
Yeah,
I've seen that with. I've seen that with like some of the smart PDUs. So I don't know if you've taken into consideration whereby the likes of Raritan or Legrand have got some in the background. I know Bachman's also developed some as well, which you can then interrogate down to almost like down to each individual sort of like connection. So that's something, but obviously that's on a smart PDU. Dumb PDUs, unfortunately, you can't do that with it. So then it comes down to whether you've not got something like a what sort of like measurement systems in there.
Yeah, another thing we were thinking about doing, which I don't know if we want to ball into this, right, was say that to be compliant with the OCP specs, you have to use the smart PDU. You can't use a dumb one, right?
It would make a lot more sense because effectively you can then measure it down to the granular level and you can actually associate. So say you've got a switch in there as well, which is going to use hardly anything, but you've got some major servers and your backup UPSs in there, that can account quite a bit. So yeah, you can then actually then optimize that as well. So that for me would be quite a sensible approach to doing that, unless you've got a really clever BMS DCEM in the background, which can go down to that level and can interrogate it via, I don't know, another way. Yeah.
I think what we want to do is first define what is needed and operationalize it. I definitely agree with you, Eric, right? If you are able to measure, you can able to measure it and really reflect the actual loss.
Right.
If you're not able to measure, you need to do a static number to put a factor in there, right?
Right. I just say that it may be more effective to talk about how it will be done and then back into how you do it in the interim.
Right.
My preference would be that you go with a smart PDU first, because that's probably the easier way, and then obviously you then look at otherwise you're then looking at the overall breakdown from an overall rack capacity. You can then measure, and then you're then looking into each and every individual part to then get the average running of it, which is traditionally how it's been done by co-location spaces when they've looked to do it from that perspective, and they normally base it on the average power supply or power consumption from the manufacturer for those units. They normally always charge at the higher end for it anyway in the background. So it depends, whether you're not what type of DC you're looking at. If it's a co-location provider, they might be a bit cross if you could put smart PDUs in, because obviously that gives the exact measurement of how that's being consumed. Yeah,
I think we should, I agree. I think we should assume smart PDUs there. And if not, what is the things we want to put it to the side? That's why I think Jeff really reviewed the OCP DMTF profiles that is currently available. When we go for that final definition, we will look at what is available and what is missing, and we'll document all those things, and we'll have a discussion on how do you operationalize it.
Right. And we'll have to talk to the management project, and we'll have to talk to the system project too, because I think we're going to, build a profile or set some of the optional things to required, right? And then get the management profile to get that management profile approved and adopted by the management team, and then we'll have to go back to the system team and tell them about it.
Yeah.
The other one I was trying to say, for when you have a common PSU shared across multiple systems, that's where I think this second point I'm trying to.
The DC, if you go back to that DC buzz bar, right, there is a benefit for this though, which we're starting to see, is if sites are now looking at hybridized data centers due to the power requirements, if they can do the buzz bar with HV directly into the room, they don't have to down convert it to AC until it's actually looking at it in the rack conversion, depending on what they need to do. It gives them a much more flexible approach. So it might be something just to consider to keep this as an option, but we then have to just, again, it comes down to in-rack measurements of when it's being brought down from high voltage to low voltage, because it gives them a lot more flexibilities within the data halls on how they can then like hybridize their approach to utilizing multiple different types of rack infrastructure without being penalized for just having one. So that's something else to consider. So just to have that, I think that is a very good idea to have that you measure it from the bus bar.
So you put one more DC converter here.
Yeah, so basically you have more converters across it, but essentially you have, so basically you keep your bus bars at HV across the entire site.
Okay.
And then it gives you a lot more flexibility within the site rather than dropping it down to AC.
So you basically put something like here, and this is used by multiple systems.
Yes.
Okay.
Yes.
Okay.
Yeah. I think then
that's not how OpenRack PowerShell 3 works, right?
No, it's not. But yeah, the problem is this is whereby you're getting into the whole world of different rack providers and different cooling solutions per rack, depending on the densities as well. So are you trying to, are we just aiming at one solution, or is it a case of looking to do it across the board?
I think we're starting with one solution. I don't know that we're aiming at one solution. So good point, right? I don't think we want to develop too big a blind spot that our methodology only works on OCP hardware. But we are definitely specifying how it's done for OCP hardware.
I think what you're saying is the models should be flexible enough to represent multiple implementations, right?
Yeah.
You may have something like this, and you should be able to comprehend that as part of the design, right?
Right.
Yeah, I think,
and one of the reasons you do that is because you don't want the same reason that PowerShell 3 went to 48 volts on the bus bar instead of 12.6. You don't want that much current, that much metal, right? The DC bus bar gets very expensive.
Yeah.
Right.
But it's less expensive, funny enough, than having to retrofit the entire site if you change it around. So,
correct.
Yeah, I think that's a good point. I think as schemas, we should put all the possible combinations. Then, if it is something not available, then it's not going to say I have it, right?
Yeah. Right. Yeah.
And I think the question here is it okay for just assuming linear attributes? For example, if you have let us say, just throwing some simple numbers, right? It's each one is 500 watts. You have 10 systems, so 5,000 watts. So you have 5,000 watts PSU. Whatever the loss, let us say you have like, I don't know, 5% loss or something, 2% loss you want to account, right? You want to divide that loss across evenly, or I mean, as long as you know the TDP. While operational,
if the load balancing is being done correctly by the design, it should be evenly being split, and it comes down to
if your rack is homogeneous, but like you said, it's probably not.
I don't know the right answer. I don't know. I'm just trying to think it through.
We know our primary partner, Meta, doesn't have homogeneous racks, right?
Yeah,
you can put to use and non-use and other things. You mix. You may put a network and everything, right?
Well, more importantly, right? If you're not gonna fully provision the network, which is expensive, especially if you don't need to, then you want to contain most of the east-west traffic inside the rack. And in order to do that, you have to put the server types you're going to talk to in every rack. And that gives you different service types, basically a hetero rack, right? So there's the front-end web servers are there, databases with and without flash are there, the caching servers there. Some of the hot storage is in every rack, right? So you end up with at least 3 different server types that have different power profiles.
Yeah, and also depending on even not everything is loaded equally, right? Even within the rack. So maybe operating idea.
Right? If they're all in the same load balancing pool and the load balancer works, they are all equally busy or not busy. All servers are the same type, right?
Yeah, pretty same type. If it's if it is a heterogeneous, then depending on what workload it's running.
If it's hetero, you lose control of it, especially because those backend services, right? The caches, databases, and the storage behind them. Some objects are hotter than others, and the servers that are lucky enough to have the hot objects have higher power and utilization than the others, right?
Yeah, because this is where it comes down to positioning within the rack. You might have 2 or 3 servers, and the first one's not doing anything, but 2 or 3 below it are then actually burning the fans out because effectively they're not getting the same airflow. So that's where the CFD modeling kicks in. But that's going to another level of detail, which you probably don't need. I'm just trying to think. Don't know. Yeah, I think, ideally, unless it is mirror for each one, you can't ever do that way.
Well, but I think the linear assumption's okay, right? If you know the challenge is if you don't have a measured inlet power on the AC and an outlet power, so you don't know what the total loss is, then you don't know what it is you're trying to allocate linearly, right?
Yeah, I think as long as they've got either smart PDUs or you've got a DCEM that's capturing the data, you can then do the load balance in the background. So you then should be in a good place to make sure the whole itself is fine. So yeah.
It is rational though that if you know the TDP of the system, sort of TDP would get us back to same power utilization on all systems, right? That's the real assumption here.
Right.
Yeah.
You don't have measured active power on all the systems, then you're making an assumption.
It's a factor, right? Once you put a factor, do you assume the factor is constant across the power envelope, right, or not, right?
The problem is you've got human beings at play here, so yeah.
Because otherwise it complicates
it's a stacked assumption, right? You're assuming that they're all equally over provisioned, and then that they are all equally busy and have the same power utilization. And neither of those is probably true. But is the error something we're going to worry about? I think is the real question.
That's the core of it. Is this? How much of a factor is this going to play? That's what I'm thinking of in the background. How much of a factor is that going to play? Because I have seen it in sites where the load balancing has been off, and it has caused quite a significant factor in the overall site sort of like performance. So yeah,
right, and that will happen, rarely, right? I mean, obviously you don't benchmark for errors, but if a system has reported some problem and has been taken out of the load balancing pool, obviously it gets real quiet on that system.
Yeah,
but now you're in some kind of a failed over state. You're going to assume that most racks don't spend much time in their failed over state, but
I think
that doesn't make it a valid condition, right?
You almost want to caveat it, don't you? Just saying as per normal load balancing or as per design of the halls being met.
We want to state our rationale, right?
Yeah.
And probably the way to resolve it would be, gin up some synthetic data. Here's what it would be measured. Here's how the estimation looks. The error between the two is X. We're not worried about that error, right?
Yeah, I think you put that rationale into it, and you've got that explanation that will then balance that out. Because I think people are like, oh yeah, that makes sense now. So yeah.
Do we want to put a linear, or do we want to put even 2 or 3 different load conditions? What is the factor you want to use it, right?
Well, the good thing, so one thing we have that, it's not public data we can point to, but we have a lot of lab data internal to our company, right? Mm-hmm. We know that there's a big step function into a power managed idle state. Once you have any kind of work on the system, if your load is even 5%, right, from there up to peak load, we are pretty linear. So the linear assumption's decent, right? The only place we're going to break down.
No, I'm looking at the power loss perspective, right?
Yeah, now that's got some other issues in it, right? We know the power supplies have a peak efficiency and usually in their mid load point, right? Like a platinum supply is 96% at 50 or something like that, and then it rolls off, right, at very high loads. And that isn't strictly linear, but there isn't a whole ton of variation either. And so again, I think, getting empirical data and trying to estimate the error with the linear assumption and justify it with some data points is probably an easy way to resolve this.
Yeah, I think putting that energy management solution in place to then try mapping it out, I think that's definitely the key to that, because then caveats it, and you can then actually then off the back of that make more sustainability improvements on the overall sites and its performance as well by then capturing that data.
So
yeah, I think, get the calibrated data for various class and then go back and, develop an equation, and you can use that as an algorithm, right? So
Right.
that may be way to start, and then you can refine, if you
Yeah.
need to do anything.
Right. Yeah, I think that's why I was thinking maybe we should get that curve and see what adjustment need to make, right? Initially, we could go with simplified. We can say a factor and the factor with our load. Then we need to figure out how do you map it, right?
Yeah, because there's then solutions you can then deploy from like a harmonics to then actually help balancing it out, and actually cause more to actually cause more efficiency as well within the system.
Right. So then we kind of looked at the cooling perspective. I think that is a third item here, like thermal losses here, right? So we looked at traditional cooling.
Loving the cooling tower. Yeah, that does scream hyperscaler to me straight away, in particular one as well. But yeah.
This is your kind of data center side, right? What we are really looking at the rack side, I think that's where I have summary there.
Yeah.
Then you have a direct to chip as well as a rear dot heat exchange. So you have a servers here with a cooling loop, and again another CDU within the rack or outside the rack. Or you may have fans, depending on how your design, right? We need to comprehend all these different factors as part of what are the things in your system or in your rack.
Yeah.
Then also we should comprehend the immersion cooling.
Yeah.
And what we said is you have all these variations here. You have fans and indoor coolers and everything. Then I think what we said is we need to understand is the fans it's a dedicated fan or shared across systems, because we are kind of looking at a system level as well as rack level, right? If it is dedicated, whatever the power consumed by the fan, you can say it belongs to that system. But if it is shared, like when we have it here, then really like that power consumption, we need to add some factor, right? The factor depends on your power consumed by a particular system versus power consumed by the whole fan side, and
so
complicates.
If you go back, obviously you've got immersion cooling hasn't got fans, but it might actually have blades, which are then actually funneling the channels, so slightly power, but again, it depends on the server sets you're looking at. DTC, again, that makes sense. That's absolutely fine. Quick question for you though.
Yeah.
Some of the EU legislation is coming out for heat reuse and heat recapture. I know you've got the primary cooling loop. The number of cryo units then being utilised though is looking to be dropped overall for some of those solutions, because obviously they're looking to maintain that heat and then actually make it viable. Have you factored that into that solution as well at all? Or are you just looking at it as what we know as of today, rather than looking at it a bit further ahead?
I think we should be looking further ahead. So what we are right now assuming is the power consumed by the rack, right? if power consumed by the chiller and other things, our assumption is if you look at here, right? It is all accounted as part of the PDU. So in IUE, PUE, sorry, IUE, we are trying to kind of, we don't want to double account, right? That's where we are trying to see, can we account only the rack side? But this side, we need to figure out how do we handle it.
Yeah.
Because if it is already, this particular cooling loop is powered by data center cooling loop, and it's going to consume power for
Well,
the,
we're assuming if there's heat reuse, it'll be off of that loop, right?
correct, this loop.
Yeah.
Right?
Yeah,
Yeah,
if
but
you go back to
yeah.
18, if you go back to 18, I think John's question is, you actually did mention heat reuse on your fourth bullet, right?
Yeah.
Right, yeah.
The question is just, do we allow for accounting for heat reuse on the rack side, or do we use that as a data center side thing, right, outside of the scope of IUE?
Well, it's being generated by the servers in the rack, so yeah.
Correct. Right,
Yeah,
but if you're using, so one other thing we didn't talk about, right? I think this IUE is not supposed to supersede PUE, it's supposed to complement it, right?
Right.
So this
Right.
isn't
Yeah.
only KPI on the data center. There is a data center PUE in addition to this IUE. And if you have a heat reuse factor, I think it applies at the PUE scope, not at the IUE scope.
Yeah. Okay, that makes more sense now. I see where you're coming from, Eric. Okay. Yeah.
Yeah, we need to account for it, no question about it. So I think it will come more to PU, definitely. Yeah.
But we have to be clear about that. So I think
Yeah,
we're having this discussion here, basically get our heads straight on what our proposal is, and then we'll go see if we can
Yeah.
get it documented in the white paper and then pass the steering committee. Great.
Yeah, sure, yeah. Thanks.
And we want to make sure that we are not accounting, double accounting. That's what you were kind of saying, right?
Yeah, I completely agree with that. So yeah.
Yeah, we need to measure it, no question about it. How we distribute it, how we roll it up, we can talk about it as I think we briefly talked in last few meetings.
Right.
And then, yeah, so we need to work on that, definitely.
So two questions here, Sami. For heat reuse, the second question, which is for what you're saying about heat reuse, we are then saying that it should be at the DC level only and not at, each of the rack level accounted. Is that what we are trying to do with heat reuse?
So we need to figure out a factor. If you want to say, I have a system, you want to advertise IUE, right? Then if I'm just giving a system level info, how do I going to factor in, right?
So you want to account for heat reuse at the rack level then? Or
even system level,
rack?
right? Yeah, think about
So
it, right?
System or rack. You don't
Correct,
want
correct.
to account for it only at DC level.
Right.
DC level, I think, is probably what Eric was explaining earlier. It makes more sense to be at a DC level from the overall PUE for the site rather than at the rack level, because you might be taking a kilometer of all the racks to then pass that heat back and make it reusable for heat reuse. Individually, it will be generating something, but it's not being utilized at that point. So effectively, all it's doing at that stage is actually dropping the overall power requirements that was being used traditionally for cooling.
I think the question is, when we say IUE, are we saying at what level, right? That's what we were thinking. We should add some suffix. If you populate it at a data center, your number may be different from just not under data center, right?
Yeah.
And we need to figure out when IUE, for a system, when we say, is it a immersion system or traditional cooling or whatever it is, right? Because when you go to immersion, all the heat exchanger, we are chiller and everything, right? This is taking away the heat, and you're accounting in the data center level. So that we should be clear when we say IUE, what does that really means? What is a system level? What is comprehending? What is not comprehending? Right.
Right. And I don't think we want. I don't think we want the higher level heat reuse factored into the local IUE. Right. The scenario that leaps to mind, right, is So say you have an immersion system that's got a whole rack in it, and you deploy that in two different locations, one of which does heat reuse and the other one doesn't. Do you want a different IUE number for those two different deployments based on whether you're doing reuse and how well you're doing?
Yeah, no, you don't, because basically it also comes down to local resources as well. So Eric makes a very, very valid point. You can have, yeah, exactly the same kit deployed at completely different sites, but effectively one can utilize it and one can't. So yeah, makes a very valid point.
So how do you comprehend that? I think that's what our question.
Well, I think the system should report the same IUE in both cases, right? I think at the data center level, your net metrics, you're going to have PUE, IUE, and others, and heat reuse would be different between those two locations, but the system itself wouldn't be different.
Yeah.
Good.
Yeah,
Okay.
that makes sense.
Yeah.
So I think we want to acknowledge that may be going on or it may not, but make a case for not trying to account for it at the system level.
Okay. So it's depending on where you're going to use the system. Your PUE will change, but IUE will not stay constant. Is that
right? Yeah, there's going to be some resource efficiency metrics for the data center, for the installation, right?
Right.
And we're not going to be able to reflect every one of them all the way down to the system level, nor would we want to, right? I don't think we want to talk about water type and water use and water stress down here either.
Right.
No, you can start opening up Pandora's box at that point. So yeah.
Right, we just overcomplicate it, right? I don't think that helps anybody.
And same thing like even WE, how do we account WE as an IE?
I just realized that I came in as a heretic. I didn't realize that. Okay.
So UUE is even darker art here. So yeah, if we're looking at DTC and it depends on the solution, then that would obviously be using it directly into the boards, because obviously that is cooling down the dielectric fluids. Immersion, again, it's not as heavy, and it can be done in closed water loop. So the complex you've got here is what cooling. Again, it comes a bit down to the overall site infrastructure. So this is then again, this is designed. What is the simplest way to look at it? What is the MEP infrastructure overall for the site, and how is it doing the overall site? So again, it comes down to a bit like the PUE, which is for the data, the overall DC. This, I think, needs to look at it exactly the same way, because that will dictate it, unless I'm missing something here.
So the question is, you may have a data center with a mixed kind of thing, right? Cooling, right? One is utilizing your heat exchanger, and another one is not using it, right? So that's why, like, air cooled versus liquid cooled all mixed up in your data center. How are you going to account for it, right? In a system level, right?
Yeah.
So that's where we need to decide how do we want to handle that. Because you may look really good, but when you start adding additional things, then yeah, there is additional factors you are just giving to somebody else to write off rather than we writing it off, right? As a system level.
Yeah, that's true. Yeah.
So one confusion, like, why are we trying to comprehend WUE or the factors within IUE?
So I think this is coming out of the EU. So the new CSRD legislation, which is Corporate Sustainability Reporting Directive, has got that all data centers are now having to report that are over 250 kilowatts, which is basically everything, have to now do the PUE, the UUE, and the CUE, which is, I was just looking down below, is the next slide. And they have to report on this, on actually what that looks like for the overall infrastructure. And that is now a reporting requirement that is coming out as of this May. And they're then going to have to report on it as a monthly on a yearly basis going forward. So it's a very, very, very valid point right now that within Europe, they've all got to be accounted for and measured. I think the US needs to do it as well, just to, again, it makes their life easier. So if, again, it's a case of that gets adopted, it comes through. I know the UK is looking to probably follow suit. So it's a very much, an industry-wide challenge that is going through as well in the background of how we look to sort of like identify this. So yeah, it's whether you look at it from an overall site level or you're looking at a rack level, which is, I don't know. That's the challenge here.
Are you sort of saying that WE is not, at a system or rack level? Like, I understand WE, CUE being reported, but I'm just trying to understand why are we saying they need to be, comprehended in IUE?
Yeah, that's the bit I'm not sure about. That's the bit I'm just trying to understand. Does it need to be incorporated within the IUE? That's the bit I'm sitting here thinking, does it, yes or no? I'm not sure.
My inclination, I think, Sammy, is just like we talked through with the heat reuse factor. I think we want to keep these at the facility level, and not try to reflect them in the rack. But that's, I guess, a postulate. It's not even a hypothesis yet, right?
Yeah, I think that's why I'm asking as a question to this work group here, right? Do we want to?
My preference would be, from just thinking about it from an MEP design level,
right,
is that this would normally be dictated by the clients for their overall site infrastructure. So the same as the overall PUE, it needs to be looked at from that higher. Yeah, it can't be looked at from a rack level, because effectively once you've got it to rack level, it's all half that solutions are already being put in place with that resourcing level. So it's, yeah, keep it at DC level. That'd be my overall input, because you're then looking at legislation, local permits, rules, everything else in the background, which will then also dictate, between one DC being 1 mile away, another DC being 2 miles away, might have completely different permit requirements of how they're looking to do it.
Okay.
Which is unfortunately the joys we have of being in Europe at times.
No, I think we want to bring this conversation so that we can say, like, we can close on the thing, right?
Right. Well, and Shruti just left, but I think, I think we take a position here, and it's really, me as the project lead and Shruti as our steering committee rep. I think we want to come up with a rationale and then see if that rationale will hold, right? If that's the position that we'll take for OCP, right? But it's good of you to ask the question, right? And have this all fully dispositioned. But I think as we describe IUE, part of what's in scope and what's not in scope and why, right? Should be one of the sections early in the document, right?
Yeah, that's a good idea. Yeah.
Right, that's a good idea.
Yeah, that will set the stage clearly, right? The information will be there, but at least as a first cut, you can propose that it'll be, these are the 5 things at a facility level, and these are the 5 things at a, right, IUE level. Then you can go back and, analyze the feedback and take it to the next level, right?
Yeah, because just thinking this through, it makes sense from a European legislation perspective. You take on board the new ISO accreditations that's been around now for a couple of years, which the Treble 237, which is at facilities and infrastructure level. It makes sense to have it at that level. So yeah, so from the DC side of it. So yeah, I'm just trying to thinking it through in my head. So sorry.
How do you operationalize it? Yeah, I think.
Yeah.
Yeah, it's, if you're putting in a system level, it's very hard to really like go after and look at it and control it, right? Yeah.
Yeah. The only thing we have to be a little bit careful about is, I've read that delegated act as well, John. In the there's a lot of kind of implicit assumptions about what data is available and aggregated for annual reporting, and I think most of those assumptions are not valid today, right?
Yeah.
So when we talk about water use, it'd be nice to know where the water is being used, and maybe there's a role to play on the IT side in terms of tracking water. We wouldn't be trying to report WUE or factor it into the IUE rating necessarily, but we may have some role to play in reporting, yes, we use water, or no, we don't, right?
Yeah, and then you get into the arguments, which we did a site in the Thames, funny enough, whereby we've got the inlet and outlet temperatures, and we had to agree with the local authority what the temperature range was going to be. So again, and also get their permission to use it. So it's again, it's better to keep it at DC level, because otherwise I think it's a case of, yeah, we don't want to take it any deeper. So
Okay. Yeah, I think that's good. I think that's good. We had a discussion on that, and
Sorry, Sam, I dropped in the middle and came back. So, but maybe that's what you summarized. We are basically going to look at whether WUE, CUE needs to be included in IUE or not, right? That we are still leaving that as an open question.
Yeah. I think what we are saying is, as a team here, right? We are agreeing that
At DC level.
keep
Yeah.
it in the DC level.
Yes, that I get.
Right.
But even at DC level, WUE and CUE, as long as they exist at DC level, do we need to include that same information in IUE also at DC level? That was my question.
Now the let's go to CUE. We didn't get a chance to discuss on CUE yet.
Okay.
Right.
Just
We and Kobe and I discussed last week, but as a team, we didn't get a chance to discuss it here, right?
So this is just a dark art unto itself, going through the carbon. So you're going for the carbon life cycle here. So again, I'll keep this operational because it depends where it's. Yeah.
Yeah, I think what I'm saying is, regardless, like there's two reasons for bringing it here, right? One is we are looking at IEE, and also we are also looking at a sustainability profile, right? As part of sustainability profile, you're going to, for a system, you're going to report IUE as well as you want to report CEE also, right?
Right.
You know the embedded carbon available. You can collect from all the devices in your system and report it, right?
Yeah.
Well, making a huge leap that data is available to be interrogated from all the inventory parts. Yeah.
Yeah. Assume as we we'll put a profile, and there is always a question mark whether available or not. If it is available, you can add them. If not, are they putting some static number or whatever it is, right?
Right, but we certainly do want to participate in the inventory and embodied carbon aggregation mechanism.
Right.
And then, maybe for operational, we report the power, and like you say, somebody else needs to know the energy input type and whether there's local generation, and whether that's renewable generation or not, and all that other good stuff, right?
Right.
Yeah, but is this taking? I get the renewables, I get the energy side. That's to do with the infrastructure and the power. Makes a lot of sense. But if are we looking at here from the embodied carbon for each and every within the rack? In which case, it's then just getting those numbers from the manufacturers and just passing those through and making sure they are clear for scope 1, scope 2, and scope 3. What the overall embodied carbon is then as a total within each rack per device per.
Going to get me into one of my favorite little rat holes here, which is
scope 3.
Someone else did a lifetime assessment, and they reported their projected scope 3. And now we're in the process of reporting the actual scope 3, right? The lifetime use carbon. You don't want to double count that.
Right.
Yeah.
So we really want to be in the business of aggregating or participating in the aggregation of the embodied data available, and then report the energy so that the operational part can be calculated and added to it. I don't think we want to aggregate estimated type 3 use carbon in addition to and add it to the actual operational carbon footprint.
No, you make a very good point there. We almost want to just do the operational carbon at that time for that device to be at that point is what we want to capture.
Right. We want to make it possible to aggregate that over time at a higher level. We don't want to try to guess.
And that should be quite a fixed. That should be quite a fixed value once it's on site and being deployed. It shouldn't then change rapidly until it goes end of life. So yeah.
So I think my question is really like when you report IEE, do we want to say some, I don't know, some operation carbon level or anything, or you want to totally make it disjoint?
Yeah, I think orthogonal has some attraction, right?
Right.
Where just like we talked about with water, right? We acknowledge that this needs to happen. We acknowledge that the rack and IT infrastructure has a role to play in generating a CUE. But I don't think we want to combine it into IUE.
If I'm thinking about this logically, no, I completely agree. We want to keep it separate because it's going to be a fixed number that's going to be within it. That's not going to change dramatically. And we just need to account for it. It's how you then look to reduce the overall infrastructure within the IUE, which makes a bigger impact. And that comes down to the energy management of the devices and smarter usage of them, or using likes of generative AI, etc., to just do something, be a bit more clever. I think if the actual operational carbons, it should always be to be there, and it's looking to be offset against it. That'd be sort of like my viewpoint on it. And it's so yeah.
Yeah, thanks, John. And one of the other motivations right here is that then we can hand that back to the carbon accounting team and run it in parallel, right? And not create a dependency between us on this point.
Yeah. Otherwise, because they're going to have that fixed number. And they're like, well, how's it changed this year? Has it gone up or down? You're like, no, it's just fixed. That's what it was. Yeah, it's not changed yet. Yeah.
So are we agreeing that we can keep the IAE and carbon related things totally separate?
I think to me it's good to keep it at the data center level, but if you want, you can double click and go down and say, hey, I have only 10 racks. What does it mean? Can you give me per rack? You should be able to, extract the data also, right?
So, but irrespective of the level, yeah, to me, it makes sense that the carbon reporting is actually kept separate, right? Like even if
sorry, go ahead.
Is there any relationship? I think that's my question.
No, we should not relate to me, my thinking, right? You can, when I say click on a data center A, you should give everything, PUE, IUE, and, WE, CUE, etc., right? And then if somebody wants to really say, hey, I have only small data center, only 10 racks, right? And then you should be able to drill down to rack level IUE and then also CUE if you want. You should be able to trace it back. That's the way you roll it up in a way, right?
No, that's correct. My question is, depending on the carbon consumption, does IUE change in any way? That's a question.
It should be indicating two different things. Like, why would you have two metrics which are, partly indicating the same thing?
No.
Like,
I'm not saying that. What I'm saying is, depending on how much embedded carbon available, is it your IEE is going to change? How much operation carbon is it going to IUE is going to change in any way? That's my question.
So
if it is going to change, then you need to relate them. Otherwise, you don't need to relate them, right?
The question I've got for you: why would the operational carbon change? I can't. If you think about it from a rack level, everything you've got in that rack primarily is being heat. I've got electricity or it's being cooled. Right. Those are the two things which the IUE is capturing and measuring, which is probably the most critical of that. Right. The overall carbon itself within the manufacture, distribution, the transportation, the install and everything else is not going to change until it goes to switch it off and then send it end of life. At which point it then has a different number, because effectively that end of life carbon needs to be accounted for either as part of that, but that again is not part of the IUE, because it's then you've then taken it out of that system, if that makes sense. So it's been removed from that rack infrastructure. So the key thing for me is, if it's in the rack, the operational carbon and the embodied carbon is going to stay the same. It's not going to, unless I'm missing something here, unless we've got some fantastic technology. The only thing I'm thinking about here is if you're looking at it for an immersion, but that's still dielectric cooling on chip DTC, you might have to replace it. Okay, the only challenge I've got here is with DTC is if you've got direct-to-chip cooling and you then have to replace any of the boards within it, you might then have an operational carbon that will then be changing because you're having to replace it, the infrastructure within it. Otherwise, it's not changing dramatically. But you should then be able to account for that within the embodied carbon report, where you're then adding or changing any components. That would be how I'd look to capture it. But that, again, perhaps I'm looking at it wrong. I'm not trying to say I've got the right answer. I'm just trying to say how I would look at it if I was a data center operator and how I'd look to report it.
Maybe I think what we do is we can take a stake. We will keep it separately now. Then when we put everything together, then we can come back and review it.
Yeah, we can, when we build a small model and go back and look at it, see how these numbers and kind of simulate various conditions.
Right.
And then maybe we may to, make the definition more, right? Accurate and clear, right?
Sure.
I mean,
we are top of
unfortunately,
the hour.
yeah. Sorry, go for it.
We are top of the hour. Probably we should continue the discussion. I think what I will do the next meeting is I will also try to comprehend this one and put some wording around to say like this is a current stake on our current route. Then we can review that and enhance it.
Right.
Yeah. Sami, can we keep the, for WUE also, whether we decided to keep it separate or not? Can we just?
And we already said, I'm just made a note.
Okay.
Right. When I write this white paper kind of a draft, right, we will comprehend that. Right. This is more of a discussion slides, right?
So we haven't decided the WE.
No, we decided we keep it separate, right? WE.
Okay.
Then again, when we do the final review, then we can, if anything that we want to discuss, we can bring it back and finalize if any tweaks need to be done.
Yeah, that sounds good.
Okay, well, next week there's 3 items I would like to get. That's the PUE white paper feedback incorporated, and also I want to get all the red face power related or sustainability related attributes. I want to bring it for review, and I will also start putting running white paper on this so that we can also have a discussion on it.
Okay, all right. Thanks, Sami.
Thank you, Tim. We'll see you next week.
Thanks, guys.
Yeah, thank you. Bye.
Thanks, Amy.
Bye.